Hello and welcome back to Maths Plus. We're continuing on the 2022 Leaving Cert Higher Level Maths Paper 1. We're on to question 4 now, which involves indices and quadratic equations. Alright, so the first part is a formula, and you can see that we have the u in over u in minus 1 within a square root. So it looks complicated, so we need a substitution there to get the outer value, and we're going to use the laws of indices, okay, on page 20 in your log table. So open those up now for these problems so that you can see what's going on with the formulas. Alright, so the first part is we want to find u to the power of p, or we want 2 to the power of p, which is a result from the equation. So let's start off. So we're going to use u3 here. So u3 is equal to, so instead of the in, we have a 2. So, you know, we're going to go in 2 plus 1, where in is equal to 2. Right, so let's put that into the formula. So let's go over here now. So u2 plus 1 is equal to u3, which is equal to u2 over u2 minus 1, which is 1. Let's write that in there. So let's place everything together. So u3 is equal to u2. Let's look up above, and we can see it's 64, and u1 then is 2. So 64 over 2. Okay, so we have root 32. So we could put that in your calculator, or let's just look at the log rules. Let's write it out comprehensively. So 32 now needs to be converted to a base number 2 with a power p. So let's work that internal part first out. So let's get the 2 to the power. So keep going with your calculator until you get 2 to the power of 2 to the power of 5, which will be 32. You do your check. And there's one more rule now which we got to do to get the completed result. So when we have a square root, we're going to go over here to the log rules. Okay, so you can see that we have like a 1 over a 2 for a square root. So we're going to go with 2, and then we have like 2 to the power of 5. Okay, and that's equal to, okay, that 2 becomes a 1 over 2 when we write it in a fractional power. So that's 2 to the power of 5. And let's look at the next rule. So we're going to multiply in when we have an outer power and an inner power. Okay, so we multiply the 5 by the half, and we get 2 to the power of 5 over 2. So not a bad question to start off with. Little bit tricky. You've got to know your indices, and just take your time and get your numbers right. Okay, so let's look at the next part. So we have a arithmetic sequence, which means we have a common difference between the successive terms. So they look complicated at the moment, but let's see what we can do, because all we need to do at the start here is to make a substitution and to reformat, okay, our information into a quadratic equation. Okay, so finally then, when we have the powers, we'll have an exponential equation then to solve. Okay, so we'll have to get the ln of both sides. So let's start it off. Alright, so looking up now, we have the 3 terms. So we can say that t1 is equal to 5e to the power minus k, t2 is equal to 13, and t3 is equal to 5e to the k. So let's get this set up. So the difference is going to be equal to any term minus the previous term, so t2 minus t1, which is also equal to t3 minus t2. Okay, so we can use this format now to put the numbers in an equation. Okay, so the first one there is t2. So we look up and we get 13 minus t1, 5 by e to the minus k with the power, and then we have t3, which is 5 e to the k, minus t2 is 13 again. Alright, so this is working out. It's balanced, but we got to kind of reformat it. So let's look up and we can see that everything is on one side, okay? So then the positive power is also on one side if we read into that, okay? So let's bring everything to one side, as we always do this when we're solving. So put a 0 here and bring everything over. So we get 5e to the power of k minus 13, and that would be a minus 26. Okay, and then we have a plus e to the minus, and we have a e to the minus k, and we have a 5 with that as well. Alright, so that's the very close now to the format above. Okay, so what do we need now to get it like identical to it? So the y has to come in now as a substitution. So we're going to substitute the actual y is equal to e to the power of k. And we're going to make a note here as well that e to the power of minus k, okay, for this value here is going to be 1 over e to the power of k, okay, which is also equal to 1 over y. And where did I get that from? Well, let's look up here at this rule. So if you have a negative power here, then we can bring it down, make it a positive reciprocal. Okay, so that's where we got it. Again, the log rules are so important. So let's put it all together. Replace the y, okay, into the where e to the power of k is. Okay, and let's get that. So we have minus 26 and we have plus 5 over y. Okay, I got that from over here. Alright, so one more step now, multiply by y, because we need a y squared, okay, as the first term variable, and then 26y, and the y's will cancel then over here, because y over y is 1, and we get 5 over 1, which is 5. Alright, so we are set up now with our quadratic equation, and that's part B. Alright, so the next part is that we got to solve the equation, and we're going to have to use the ln, okay, and remember the ln and the is also equal to log to the base e, which is used to bring down the power for the exponential function. So let's put everything together. So let's write 5y squared minus 26y plus 5 is equal to 0. So now we're going to solve it. So let's factorize real quick. So we go 5y, okay, by y is 5y squared. And remember 5 by 5 plus 1, y is 25. Okay, so there will be the cross multipliers, and they're both negative in the brackets as they multiply to give a, okay, to give a plus 5, and they add to give the cross multiplier. So the 5y by 5 is 25y. We'll make it negative, and then over here then we have minus 1y, and that will give the cross multiplier result of minus 26y. Right, so it works out. Alright, so if we have the factors, we can get the roots now. So let's start off. So 5y minus 1 is equal to 0 on the left hand side, and y minus 5 is equal to 0 on the right hand side. So 5y is equal to 1 and y is equal to 1 over 5. Okay, and then we have y is equal to plus 5 over here. Alright, so we have the two y values. Now we need to substitute back. Okay, and remember y is equal to e to the power of k. So e to the power of k is going to be, replace this one. So we have 1 over 5. And on the other side, e to the power of k is equal to 5. So we'll have to look up now, because we have to get ln p or minus ln p. So these are specific formats we need to work towards. So let's look at the log rules. So if we want to bring down the power with the ln function and the exponential function, we're going to apply this rule over here in the log tables. So a matched base, okay, so ln of e or log to base e is equal to ln, and then that will bring down the power. Okay, this one over here. Okay, so we go ln of e to the k is equal to ln of 1 over 5. Okay, so k is equal to ln of 1 over 5. Alright, so what we're going to do now is we're going to make the 5 a 5 to the power of minus 1. So that'll be equal to ln of 5 to the power of minus 1. Okay, and let's use the log tables. So over here we brought this power up. Okay, so it's negative from the fraction, and now because we have a power here, we're going to bring it out in front, and that will give us minus ln, as in the question up above, you know, up here. So it's going to be equal to minus ln of p, which is minus ln of 5 in this case. Okay, so that's the equation 1, or solution 1. And what about solution 2 over here? Well, we just do the ln of both sides, and we get k is equal to ln of 5. And there are 2 solutions. So I hope you enjoyed that. It's a pretty challenging question, but the exponentials are challenging, but they're worth studying because they're straightforward. So thank you for joining Maths Plus, and look out for the next video, which will be very soon.